Basic Geometry Self-Test Number 2. You'll need some paper and a writing instrument for this self-test. This test is just a basic geometry self-exam. It works like this. I'll show a problem. You click on the stop sign above. That pauses the video if you're watching on YouTube. Then you try to work out the problem on a piece of paper. When you feel satisfied or frustrated, then click on the go sign above and I'll step you through the solution. Of course, you can always watch the solution again, or skip the problem altogether if it's just too elementary for you. Just use the slider bar below the view screen to advance to the next problem. The type of geometry that we will be addressing here is the geometry of Euclid, a Greek mathematician who lived about 2,500 years ago. We'll study Euclidean geometry. For a few thousand years, all geometries were Euclidean geometries because the new geometries, the non-Euclidean geometries, have only recently been invented or discovered. A few thousand years before Euclid, the pyramids were built using basic geometry. With just some string, you can make straight lines and arcs, and that is the foundation for basic geometry. Euclidean geometry can simply be thought of as the geometry of points, lines, planes, triangles, circles, squares, spheres, cylinders, cones, and pyramids, to name a few basic geometries. Points have no dimension. They are just locations in space. Lines have one dimension that we call length. Planes have area, and that is just length in two different directions. Cubes have volume, which is just length in three different directions. Here we have the x direction, and you can see that here by the red lines. Now we have the y direction, and you can see that here by the red lines. And then you have the z direction, which we can see here. So the cube has x, y, and z. That gives it volume, or units cubed. Sketch a right triangle, and then name 6 different parts or aspects of it. Click on the stop sign. Okay, let's see how you did. Well, right triangles have legs, as opposed to non-right triangles that have sides. Right triangles have an altitude, and it just so happens that the altitude is the same length as the leg. It's not always the case in the when you're dealing with non-right triangles. We'll take a look at that a little bit later. A right triangle always has a hypotenuse. The hypotenuse is always opposite of the right angle, and the hypotenuse is always the longest line, the longest side, if you will, in a right triangle. This right triangle has area. It has 2 acute angles, and the acute angles always sum to 90 degrees. And acute angles, they always sum to 90 degrees, excuse me. It has a right angle, or a 90-degree angle. All triangles sum to 180 degrees, that is the internal angles. This triangle has a perimeter, which is just adding up the total length around, just like a fence, so it would be the total distance all the way around. And it has a formula for finding its area, base times height divided by 2. All triangles are exactly 1/2 of a rectangle. That's why you have the formula for finding the area of a rectangle, base times height, and then you divide it by 2 because all triangles are exactly 1/2 of a rectangle. Number 2, sketch a non-right triangle and name 5 different parts of it. Click on the stop sign. Alright, let's see how you did. Well, here we have an obtuse triangle. It has internal angles that sum to 180 degrees. Here we have 2 acute angles. Sometimes you'll have 3 acute angles inside a non-right triangle. Here we have an obtuse angle, one that is larger than 90 degrees. We have an area, and the formula is the same, base times height divided by 2. The height here is the altitude, and we'll take a look at that in a second. This triangle has a perimeter, which means you just find the length of the sides and add them all up. The altitude is a 90-degree difference, this line right here, that is made off of a straight line coming off of one of the sides. Then you measure it up, and that is the altitude of the triangle. Notice that the altitude is not the same length as this side of the triangle. So finding the altitude of a non-right triangle sometimes can be tricky. It is exactly 1/2 of a rectangle. So you see here exactly 1/2 of a rectangle. Sketch a non-right triangle and name 5 different parts of it. It has sides, not legs and a hypotenuse. Non-right triangles have sides. It has angles, 3 of them, and of course you already know they sum to 180 degrees. Number 3, click on the stop sign and see if you can solve the problem. Alright, let's see how you did. Well, in the sketch below, line DB bisects angle ABC. So this line right here, this is a sketch now, this line right here, BD, bisects angle ABC, which means it splits it in half. If angle ABD is 32 degrees, what is the measure of angle ABC? Well, if this is 32 degrees and this is the angle bisector, then this also is 32 degrees. 32 plus 32 is 64 degrees. If you got 64, you're doing it right. Alright, number 4, click on the stop sign, see if you can solve this. Alright, let's see how you did. It says, in the sketch below, line DB bisects angle ABC. If angle ABD is 4x minus 2 degrees, what is the measure of angle ABC? Well, it turns out there's not enough information for you to solve this problem. You need to be prepared for sometimes there not to be enough information for you to solve a problem. Now, what we would need to know is what is this equal to? So if we knew this amount right here, or if we knew some equation that was this amount right here, we would then be able to solve the problem. Click on the stop sign, try to solve the problem. Alright, let's see how you did. In the sketch below, line DB bisects angle ABC. If angle ABD is 4x minus 2 degrees and angle DBC is 3x plus 6, what is the measure of angle ABC? Well, let's see how you did. First of all, you would recognize that this is the angle bisector, and the angle bisector, it tells us that this angle right here is 4x minus 2, and this angle right here is 3x plus 6, which now just turns it into an algebra problem. So we set 4x minus 2 equal to 3x plus 6. I add 2 to each side, getting rid of this 2, so I now have 4x equals 3x plus 8. Subtract 3x from each side, and I wind up with x equals 8. Go back and reread the original question, and it says, what is the measure of angle ABC? X equals 8 is not the right answer. It's on the way to finding the right answer. I need to plug in the x equals 8 into this and this, add them together to get what is the total measure of this. So I go 4 times 8 minus 2 equals 30. And 3 times 8 plus 6 equals 30. 30 plus 30 is 60 degrees. So if you got 60 degrees, you're doing it right. Number 6, read the question. Click on the stop sign, read the question. Alright, let's see how you did. It says, in the sketch below, line AB is perpendicular to line BC. Angle ABD is equal to 2x plus 1, and angle DBC is equal to 3x minus 1. What is the value of x? Alright, this is a sketch, so we can't really trust the drawing. It's just give us an idea of what it looks like here. And it says that AB is perpendicular to BC. That means this is a 90-degree angle. Doesn't look like it here, but the information tells us that this is 90 degrees. And then it says that we have this angle right here, this line right here. Doesn't say anything about this line right here being any kind of an angle bisector. So this angle right here, it doesn't tell us is equal to this angle right here. So, but we do know that this plus this, these are complementary angles, so we do know that they total to 90 degrees. So, what does that mean? Well, that means that we know that it's 90 degrees, so we know that 2x plus 1 plus 3x minus 1 is equal to 90 degrees. So we say 2x plus 1 plus 3x minus 1 equals 90 degrees. Grouping like terms, we wind up with 5x equals 90 degrees. Divide both sides by 5, and we get x equals 18. Go back and reread the original question to find out what it was, and it says, what is the value of x? X is 18 degrees. you could check that by plugging it back in to see if it gave you 90 degrees. Number 7, click on the stop sign and see if you can solve the problem. Below is a sketch of vertical angles. Make your own sketch and fill in as much information as you can. Okay, we'll rip through this kind of quickly. Here we have the vertical angles. And vertical angles, that just means that we have two lines that have crossed each other, two straight lines that have crossed, and that forms vertical angles. And what we know about vertical angles is the opposite angles always equal each other. They're congruent. This angle is congruent with this angle, and this angle is congruent with that angle. We don't know what they are, but we do know that these are congruent, and we do know that these two angles right here are supplementary, these two angles right here are supplementary, these two angles right here are supplementary, and these two angles right here are supplementary. We still don't know what they are, but we do know that supplementary angles total to 180 degrees. All right, if this is 30 degrees, this is 30 degrees. If this is 30 degrees, then this is 150, and this is 150. We know that this angle measure right here is exactly equal to this angle measure right here. We know that this angle measure right here is exactly equal to this angle measure here. We know that they total to 360 degrees. We know that these two angles right here are supplemental. We know that these angles right here from A to B are 210 degrees. We know that these two angles are supplemental. We know that the distance from A to B is 330 degrees. All right, that concludes things that we knew about that. You might have come up with a few more. Number 8, click on the stop sign, read the problem, then come back and see me work through it. All right, line AB is a straight line. Line MN is a perpendicular bisector to line AB. Line T is an angle bisector. Sketch the drawing and fill in as much information as you can. Alright, so what this tells us is that this is line AB, and this is the perpendicular bisector. And this is an angle bisector from these two right here. And if it's a perpendicular bisector, we know that this is 90 degrees, so we automatically know that this would then be 45 because it bisects the angle. So, alright, we knew that that was 90 degrees, we knew that that was 45 degrees, we know that the others are 45 degrees, we know that's 90 degrees, we know that the distance from A to 0 and 0 to B are A to the origin and the origin to B. We don't know what they are, but we know that they're equal to each other because this is a bisector of that. We don't know if the distance from M to the origin and N to the origin are the same. It doesn't give us enough information to know that. We know that this angle is congruent with this angle, which is congruent with this angle, which is congruent with this angle. We know that the slope here then is rise over run is 1 over 1, and so our slope is a positive 1. We know that this is the origin, and we know that if this is a positive 1, that the perpendicular, a line perpendicular to that slope would be a negative 1. Doesn't matter where we put it either. Another perpendicular slope would be a negative 1. All right, how many values of M are shown in the sketch? Click on the stop sign. Let's see how you did. Well, turns out there are 13 M's. Here I have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, let's see. We have 13 M's, so we know that 13M plus 30 is 360 degrees. Subtracting 30 degrees from each side, I wind up with 13M equals 330 degrees. M, correct to 2 or 3 decimal places, is 25.384. It would go on for much longer than that, but this is correct to 3 decimal places. 25.384. Make a sketch of the graph of x equals y minus 2. Click on the stop sign. Okay, let's see how you did. Well, a couple of ways we could do this. We could have put it in the slope-intercept form, or if you don't know how to do that, another strategy would be to just start sticking in some numbers and get ordered pairs. In other words, if I stick in a y equals 1, so 1 minus 2 is negative 1. So the ordered pair for that would be negative 1, 1. If I stick in y equals 2, well, 2 minus 2, that's 0. So x is 0, y is 2. And if I didn't know how to put this in slope-intercept form, I could just stick in a value of 3 for y. 3 minus 2 is 1. So when y is 3, x is 1. Now I can plot those points and draw a line that would look about like this. Or, if I know how to do the slope-intercept form, I can take a look at this and say, alright, x equals y minus 2. If I add 2 to each side, then I have x plus 2 equals y. Now this is in the slope-intercept form, but written a little backwards. So I move the y over to the other side, and I move the x plus 2 to the other side, and just swap them around, turn them over. And so when I do that, the signs don't change. I wind up then with y equals x plus 2. I know that the slope of my line is going to be a positive 1, and I'm going to cross the y-axis at positive 2. So my slope is 1. And I cross the y-axis at positive 2. Same thing, both ways. One of them was a little easier by putting it in the slope-intercept form. Make a sketch of the graph of negative x equals y plus 1. Click on the stop sign. Okay, let's see how you did. Well, we need to put this in slope-intercept form, which means that, let's see, if I move the y, let's see. Alright, make a sketch of the graph of negative x equals positive y. If I subtract 1 from each side, then I wind up with negative 1 minus x equals y. Swapping, turning it around, I then wind up with y equals negative x minus 1. So the slope of my line is going to be a negative 1, and I'm going to cross the y-axis at negative 1, and here I have that. So if you did something that looks like this, you're getting it right. If you need a little extra help with this, watch the tutorial that I have on graphing or using the slope-intercept form. 13. In which quadrant does the green dot lie? Click on the stop sign if you need to. Falls in the third quadrant. We know that's the third because if I start here, this being the first quadrant, and I draw the capital letter C, I go through the quadrants in their order. 1, 2, 3, and 4. 14. In which quadrant does 4, negative 2 lie? Alright. X is 4, Y is negative 2. We are in quadrant 4 because clicking on the, or writing a capital letter C would come around like this. Number 15. Click on the stop sign, try to solve the problem. Alright, let's see how you did. It says if the slope of line T is 1 and line P is parallel to line T, what is the slope of line P? Well, if they're parallel, the slopes are the same. So they are both a slope of positive 1. Parallel lines have the same slope. 16. Click on the stop sign. Alright, if you made something that looks about like this, rise over run, our rise is 1 and our run is 2, and it must pass through the origin, and I've done that here, so I rise 1 and I go over 2, I rise 1, I go over 2, I rise 1, I go over 2, plot a couple of points, draw a straight line that passes through them. If you did something about like this, you're doing it right. Number 17, click on the stop sign. Alright, let's see how you did. Let's see, make a sketch of a line with the slope of 1/2 that passes through the origin. We've already done that. And then sketch a line perpendicular to the line that has a slope of 1/2. So we're going to make a line that's perpendicular to a slope of 1/2. So it would look about like this. Here's the slope of 1/2, up 1 over 2, up 1 over 2, up 1 over 2, and a perpendicular line would go up 2, negative 1, up 2, negative 1, up 2, negative 1. Or we could say that the run is 1 and, or so I started right here, excuse me, negative 2, positive 1. So negative 2, positive 1. Either way, it gives us the same slope. So if I have a slope of positive 1/2, its perpendicular is negative 2. A line that has a slope of 1/3, what is the slope of its perpendicular? Click on the stop sign. All right. If the slope is 1/3, its perpendicular would be a negative 3. Here you see kind of a picture that I've drawn of that. This is a slope, a positive slope of 1/3, and here we have a negative slope of 3. Number 14. All right. A line that has a slope of negative 1/4, what is the slope of its perpendicular? Well, it turns out it's 4. Here I have the slope of negative 1/4, and its perpendicular would look like this blue line here, and it would be a positive slope of 4. Click on the stop sign. Okay, if you made a sketch that looks about like this, you're doing it right. Very good. A right triangle, click on the stop sign. All right, so if you drew something that looked about like this in the second, third, and fourth quadrants, you could take a look at this now and you could hammer this out. You can say, okay, the distance from here to here is 1, and the distance from here to here is 3. 1 plus 3 is 4. And the distance from here to there is 1, and the distance from the x-axis to up to positive 2 is a total of 3, and it's a right angle, so we would have the 3, 4, 5 triangle. If these numbers were not 3 and 4, you could use the Pythagorean theorem to figure out what the length of the hypotenuse was. What does this symbol mean? It's a triangle. Meaning that if you see that, hey, just read it like the word triangle. This means angle. Perpendicular. Parallel. Equal. Plus. Congruent. Degree. 90 degrees or a right angle. Line segment. Line. Division. The red line means division. All right, so let's take a look at this. M is parallel to N, so line M is parallel to line N. Then we have the transversal here, and we're asked, is angle 5 congruent to angle 6? No, they're not congruent to each other. They're supplementary. Angle 5 plus angle 6. We don't know what they are. We do know that they total 180 degrees. Is angle 5 congruent to angle 8? Yes. Vertical angles are congruent. Is angle 3 congruent to angle 6? In other words, this angle here, is it congruent to this angle here? And the answer is yes. Is 5 congruent to 7? No, they are supplementary. Is 4 congruent to 1? Yes. Triangles are congruent. This little symbol right here means that they are congruent when they meet certain criteria. Side, side, side. The lengths of the sides are all the same. Then they are congruent. Side, angle, side. When the lengths, or when the side is congruent to another side, the angle is congruent to the other angle, and the side is congruent to the other side. The triangles are congruent. The angle, side, angle is congruent to the angle, side, angle when all three are congruent. Angle, angle, side, here I have an angle and a side. This is not the included side. It comes on the outside of this. And you could say side, angle, angle. So we could say side, angle, angle, and these are congruent. When you're dealing with right triangles, there are four ways for you to prove congruency. The legs are congruent with each other because we only need two things, because a right triangle always has a 90 degree. The leg and the hypotenuse, when they are congruent, the triangles are congruent. The hypotenuse and the angles, so this hypotenuse and this acute angle, this hypotenuse and this acute angle, when they are congruent, the triangles are congruent. The leg versus an angle, when a leg and one of the acute angles are the same as the leg and an acute angle on the other triangle, they are congruent. Take a moment and make a sketch of the 8 ways that triangles are congruent. Click on the stop sign. Alright, triangles are congruent when they meet certain criteria. Side, 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 angle, side, angle, side, angle, 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 side, leg, leg for right triangles, leg, hypotenuse for right triangles, hypotenuse, angle for right triangles, and leg angle for right triangles. Triangles are not necessarily congruent because of angle, 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 or angle, side, side. Let me give you some examples. Here I have two triangles, both of them are equilateral. So it is easy to see that these two equilateral triangles are not congruent, though they have the same angle, angle, angle measurements. In other words, 60 degrees, 60 degrees, 60 degrees, 60 degrees, 60 degrees, and 60 degrees. They are not congruent triangles. Here we have the side, or angle, side, side method, and so here I have 30 degrees and 30 degrees. This length is 4 units long. This length is 4 units long. This length is 2 units long. This length is 2 units long. It should be easy for you to see these are not congruent triangles, although they have angle, side, side congruency. The triangles themselves are not. A building's height is not known, so a mirror is set on the flat ground between it and a man. The man looks into the mirror until he sees the top of the building. He then makes 3 measurements to calculate the height of the building. A sketch of this follows. What is the height of the building? Click on the stop sign. Alright, let's see how you did. Well, it turns out that what happens with a mirror is the angle of incident is equal to the angle of refraction. So if the mirror is flat on the ground and the ground is flat, you can then set up proportional triangles this way. So what we really have here is we have a triangle that we don't know this length of the leg right here. It's a right triangle. We don't know the height of the building, but we can know that this is 40 feet and the distance from the center of the mirror to just under the guy's eye is 6 feet and up to his eye is 5 feet. So we set those up in proportions of the unknown as the numerator and the known 40 as the denominator is proportional to the height to his eye to the distance from his feet to the mirror. Then we cross multiply. So if we cross multiply, we have 40 times 5 is 200. We also know, since we're cross multiplying, that x times 6 is also 200. It now just becomes an algebra problem. 6x equals 200. Dividing both sides by 6, we wind up with x equals 33 1/3 feet. The height of the building is 33 1/3 feet. Look at it and see if it makes any sense. In other words, the distance from the center of the mirror to the guy's feet are at 6 feet, and he's 5 feet tall. So that means that the distance from the mirror to the base of the building is 40 feet, so we should be looking for an answer that's a little bit less than 40. And it turns out 33 1/3 feet is less than 40. Alright, below are 2 proportional triangles. What is the length of x? Click on the stop sign. Alright, let's see how you did. Well, we cross multiply here. We know that this length right here is 20 feet, and we know that this length right here is 33 feet. So we set this up 20 as the numerator, 33 as the denominator. We take the height here, make that 3, and we don't know the x. So we cross multiply. 33 times 3 is 99. We know that 20 times x is also going to be 99, so we set up the algebra problem. 20x equals 99. Divide both sides by 20, and we come up with x equals 4.95 feet. And look at this. Does that make any sense? Here we have 20 feet, and this leg is considerably longer. Not double, but getting close. So here we have 3, and this is almost 5. So does the answer seem to make sense? Yes, it does. All right. Before we get into a couple of questions here, or a little bit of a review, a median of a triangle is a line that passes from the vertex to the midpoint of the other side or leg of the triangle. So it passes to the midpoint. It is not an angle bisector. A median is not necessarily the same thing as an angle bisector, though they can be the same thing when dealing with an equilateral or an isosceles triangle. Here you see an equilateral and an isosceles triangle. When dealing with an equilateral or isosceles triangle, the median is the same thing as the angle bisector. In other words, this is the median because it comes to the midpoint, and it is also an angle bisector, and this is 90 degrees. You don't necessarily have that in a scaling triangle. Here we have a scaling triangle. All triangles, therefore, have 3 medians. Each median passes through the center of gravity of the triangle, and this is known as the centroid. So there you see the centroid. Line AB is a median, not a bisector, and the green area is equal to the blue area, though they are not congruent triangles. In other words, this area right here is exactly equal to this area right here, though they're not congruent. The areas are the same. Line CD is a median, not a bisector, and the white area is equal to the black area, though they are not congruent. In other words, the white area here is the same amount of area as the black area here. Line EF is a median, not a bisector, and the blue area is equal to the purple area, though they are not congruent. So this blue area is exactly the same amount of area as the purple area. They're just not congruent triangles. And interestingly enough, all 6 of the smaller triangles that are made by the 3 medians are equal in area, though they are not congruent. What is the name of the red lines below? Medians. What is the name of the point at which the medians cross? Centroid. What is the name of the point at which the medians cross? Centroid. What is an interesting point about the centroid? If the triangle is uniform, meaning made out of the same kind of material, it's the center of mass or gravity of the triangle too. Your comments, questions, and suggestions are welcome, encouraged, and always appreciated. You may write to me at alanmorris@yahoo.com.